Good morning, MSU1s. Good morning, future elementary educators. Good morning, future science teachers. I hope you enjoyed our forum. The teaching is like fishing forum in our BLE. And let me remind you again with a statement. Teaching is like fishing. You use different lures for different fish. You use different methods for different learners. You also got excited when you were tasked to review the lesson plans of the science teachers in the field. And we just had a very interactive presentation about your analysis of the lesson plans of the science teachers in the field. So today we're going to work on discussing the different methods that you're going to fish so that you will be able to deliver the concepts well in your science class. So let me just share you a slide presentation. All right. So talking about methods in teaching biology and chemistry, we need to start by defining what a method is. So when we say method, it is a series of actions aimed at achieving the learning targets. There is another statement here in the slide that says it is the overall effort consists of structured procedures based on the selected approach. So from the approach or the teaching approach that we are using, we are to follow different processes, different steps for us to be able to achieve our learning targets. And this could be series of activities that we're going to employ in the class, but take note that we carefully design this repertoire so that we will be able to successfully achieve our learning targets. So there are 8 methods of teaching science that we are going to discuss in this video presentation. The first one is concept attainment method. The second is the free discovery method. The third is inductive method. The fourth is guided discovery method. The sixth is inquiry method. Seventh is experimental method. And eighth is problem solving method. Now, let me start with the concept attainment method. So take note, class, that concept attainment method is a constructivist approach to education and learning based on Jerome Bruner's work. So this is part of Jerome Bruner's work. Through the procedures of comparing and contrasting. So when we say comparing, we look at the similarities, and constructing, we look at the differences. Students use their existing knowledge to determine the characteristics of an idea in this instructional paradigm. So since it's a constructive-based, it's anchored on the constructivist approach, so we also invest on the prior knowledge of the students, and this prior knowledge of the students will be used by them in looking at the similarities and the differences of the concepts they are into or they are discussing. So this is the process because we are talking about method here, and we acknowledge that when it's a teaching method, we follow step-by-step process. We have a structured procedure. It's a series of actions. So in the concept attainment method, these are the series of actions that we need to follow in order to achieve our learning target. So it is categorized into 3. So the first one is the presentation of data and identification of the attributes. So when we work on presentation of data and identification of attributes, these are the processes or the steps that we're going to follow. One is to state the purpose of the game and explain the procedure. So there's a term here, it's a game, because like when you ask the students to be comparing and contrasting the concepts that are associated with what they are discussing, that They've got to be going back to the prior knowledge so that they can identify the differences and the similarities of the concept. So it's kind of teacher can facilitate a gamified learning for this concept of attainment method. Um, we also have to present the initial yes example, which clearly contains the attributes. So, meaning to say, we have to be presenting to our student an example of an attribute of that particular concept that we are presenting to them. The third one is we ask the students to contrast the yes examples and the no examples as the game proceeds and after the presentation of several examples. Then, on the fourth step, you have to encourage the pupils to join by giving further examples as they recognize the concept. So, upon knowing that the students have already recognized the concept, it's your task as a teacher to facilitate or to encourage them to also join the giving of a yes and the no examples. And the fifth one is ask the students to name the concept and state its essential attributes. So this is more now of facilitating or building a generalization out of the yes and the no examples. Now, the second column here talks about the teaching attainment of the concept, and there are two processes here, or there are two steps here. So, first is present additional examples and ask students whether they contain the concept. And the second one is encourage students to give their own examples to the concept and justify them by identifying the essential attributes. So this is now about teaching the attainment of the concept. This is where the teacher will ask the students to give more examples or discuss more examples so that mastery will be ensured in that process. And the last one here is the analysis of the thinking strategy. So in the analysis of the thinking strategy, teachers have to ask the students to name, describe the thinking processes they use in obtaining the concept and evaluate the effectiveness of them. So it's more of recognizing, or it's more of the teacher facilitating the students to recognize what strategy they think did they use in order to arrive at the concept that they are discussing in the science class. So those are the different steps that you need to follow whenever you employ concept attainment method. Now, the concept attainment method has merits, and these are the following. One, it helps the learners make learning between what students know and what connections they will be learning, because it's a constructivist approach. And remember that the students build their knowledge from their uh, prior knowledge and experiences, or help in building the knowledge out of their prior experiences. The second is pupils learn how to examine a concept from a number of perspectives, because remember they have to check whether that's a yes or no, or that is that example a yes for that concept, or is that example a no for a concept. The third is it provides strategy for the learners on how to sort out relevant information. So, of course, they will be able to categorize, or they will be able to identify relevant information based on what is discussed in the science class. More merits of this method, it extends the pupil's knowledge of a concept um, by classifying more than one example of that concept. Remember that even in the teaching of the or teaching of using this method, teachers have to be giving a lot of examples. Even the students are encouraged to give examples so that they will be able to build that generalization from the lesson. Then here, students go beyond merely associating a key term with a definition. So the learning here is not surface because learning here is not about defining only what the concept they are discussing, but it's also illustrating, it's also giving more understanding by giving examples or illustrating by giving examples to the concepts that they are learning. And of course, concept is learned more thoroughly and retention is improved. Yes, because there's a process that is going on. There is an engagement in the learning process. There is an active participation of the students in building that concept that they are discussing. Now, if there are merits, the concept attainment method has also demerits. But I think it's only one. So it's demerit. So miscommunications in concept attainment could be a drawback to the educational process. So whenever you employ concept attainment method, you have to make sure that effective communication can take place because one of the drawbacks of the concept attainment method is the miscommunications of concept. So there might be a tendency that students will misinterpret um, this the concepts or the processes that they are going to engage in this method. Now, in teaching science, of course, we sometimes follow inductive reasoning as shown in the slide. So when we do inductive reasoning, we do observation, we look at the patterns from our observation, we have this tentative hypothesis, we check whether our hypothesis from our observation is evident, and from there we come up with a theory. And this is probably the reason why inductive method is very applicable in science teaching. So when we say inductive method, we teach from specifics to general. So meaning to say the in this method, the students have to explore first before they are going to come up with generalization. So how do we do the inductive method? So when we are going to use this method, these are the steps. So we start with motivating the students. So we can probably initiate an activity in our class where students can be hooked to what we're gonna do in the class. And then next is presentation. Presentation probably of the specifics or even examples of the concepts that we are talking about in the class. And after that, we do comparison and abstraction based on the data that we have. Of course, this data must be coming from the students. And of course, we ask the students to give based on what they know. And then from comparison and abstraction, we do generalization. And then when we have that generalization already, we have to provide opportunities for the students to apply. And then, of course, we evaluate whether that generalization has been understood by the student. So in the inductive method, we go specifics to general. So what are the merits of inductive method? So take note that it's meaningful and memorable lesson because I think this is more of deepening first before they come up with a generalization. The students will discover themselves. It stimulates students' cognition because students have to think. They are not going to be listening to the teacher, but they are engaged in the process. And active and interesting lesson. Students are actively involved in the lesson. They become attentive and motivated, and it's a student-centered. And in this method, there is a a two-way communication, but sometimes it could be a three-way communication because there could be a communication between the teacher and the student, the teacher, and the teacher to students, students to teacher, and students to students. So um, the learning process in the science class when you use the inductive method is engaging in that students get motivated or they would have fun because they feel that they are involved in the learning process. What are the demerits? So it's time taking, especially when the students have difficulty in processing what you are facilitating in the class. And sometimes it can frustrate the students who prefer simply to be told the rule because there are students who have a learning preference that they wanted to start with generalization before they go into the specifics. Um, then, of course, learning styles and ability to discover themselves because of learning modality that they prefer. And students may reach false conclusions. So we have to be very careful whenever we use inductive method and we make sure that students will reach conclusions that are true and not false. Now, we move on to the next method, and that is discovery method. So what's a discovery method? It's a method in which the teacher does not provide end material, and the students must organize their own using the teacher's stimulus. In here, the teacher serves as a guide throughout the learning process, and the instructor provides opportunities for pupils to be active learners. So from the word discovery, the students here are going to discover the this is going to be fun because the students will unleash something about science and they have to be discovering something about science. So how do we do that? Because our focus here is the step-by-step process that we're going to do in order for us to achieve the learning targets. So when we use the discovery method, there are two types of discovery method that we can probably employ. So depending upon the kind of learner that we have. But before I go to the different steps, let me just tell you about the different principles that we follow whenever we push for the discovery learning. So there are actually 5 in the screen. So let me just read the different principles. So when it's discovery method or when you follow the discovery learning model, it follows the principle of problem solving. So in science class, there are always problems that we need to solve or we need to give solutions. So when we say problem solving, it's a problem solution process. So you have to be finding ways in order to solve the problem. And of course, in this process, um, teachers can encourage and motivate the learners to combine their previously acquired and newly acquired knowledge and simplify that knowledge in order to explore solutions to the problems that they are into in the science class. So the activities here are actually promoting risk taking, problem solving, and probing, and that learners become the driving force behind learning and take an active role and build broader application skills. Now, the second one is a learner management. So, what it is, in here, in this discovery learning model, the teacher encourages the learners to work alone or collaboratively and at their own speed. So they have to do self-learning and that they collaborate, but they have to be at their own pace. So looking at the this principle, the discovery learning is flexible. And the flexibility transforms learning into polar opposite or a rigid sequence of courses and activities, relieving learners of unnecessary stress and empowering them to take ownership of their education. The third principle is integrating and connecting. So take note that discovery learning is process driven rather than content driven. So the focus of this model is really on the process. And this model is predicated on the premise that learning is not a collection of facts. Instead of memorizing the correct answer, students learn to analyze and understand the learned information. And that I think is information analysis and interpretation. I'm sorry. So that's principle number four. So what I was explaining was principle number four. So when we say principle number three, integrating and connecting, teachers should demonstrate how to integrate past knowledge with new information and inspire learners to make connections to the actual world. Um, they can you can probably provide familiar scenarios where the students can relate so that they can easily get into the lesson. And the last principle is failure and feedback. Not all learning occurs when we discover the correct answers, and it can also arise as a result of failure, like our previous scientists. So the goal of discovery learning is not to achieve the desired outcome, but to discover new things. And we say eureka after discovering new things. So the teacher's job here is to provide feedback as learning is incomplete without it. So very important that we provide feedback, especially when the students will get into the failure, because maybe the students will get frustrated with whenever they they encounter failures as they go to discovery learning. So there are two types. One is that of Jerome Bruner, and that is pre-discovery method. And the other one is from Robert Gagne, the guided discovery method. So for the pre-discovery method, so it starts with an unstructured free inquiry. So what do we do here? We present question or problem, then show materials, allow time and opportunity to for the students to explore the materials. Then we go to the free exploration stage. And under the free exploration stage, we have the pupils pursue the problem that they have identified, guide the children to get through the inquiry process, and third, trial and error or messing about the activity. So they have to mess about the activity in order to unleash something about science. Um, and then they are into free, they then proceed to the free discovery. Um, we teachers have to be facilitating the pupils to share findings from their exploration and provide them with opportunity for to theorize and give, argue, or pursue further study. And then after that, that's the application. Now we move on to the guided discovery method. So in the guided discovery method, we recall previous learning experience, show materials for learning such as pictures or real objects or realia, diagram or real scientific phenomenon. And of course, they ask questions that may lead to the problem. So very important in the discovery method that um, the the ability of the learners to ask questions so that they can find solutions to that problem or they can generate information out of that problem. Then the guided exploration here first perform series of activities using concrete materials, and that they have to follow a step by step procedure in performing the activities, and that can be um, or the students can be guided by the teacher in doing so. And then gather and record findings. They have to organize also the findings. And then fourth is report the findings to the class. So in the guided discovery, of course, you here as a teacher becomes a facilitator. So you guide the students in interpreting the findings, and that you guide the pupils or students in formulating the concept. You apply, you make them apply and evaluate and make an agreement for the next activity. So what are the merits of the discovery learning model? So one is encourages active participation among the learners because they are engaged in here to be so that they can unleash new ideas or new concepts, new theories. It develops students' problem solving skills. For demerits, take note that not all students can follow the lesson in this way. There are students of different learning modalities. So they might get frustrated, they might get disappointed because they will have difficulty in following the lesson this way. Not all topics also are suitable for this method. There are topics that you cannot use discovery learning model, um, like building concepts or building concepts, because in building concepts we have to be using concept attainment method. Now we move on to inquiry method. So take note that the inquiry method is based on emerging information about learning process from research. So children become involved here in a variety of the activities and thought processes that scientists use to generate new information through inquiry-based science education. So in an inquiry method, the students are going to ask questions and they are going to answer. So this is based on the process of doing research. So how do we do the inquiry method? The first one is we confront the students with puzzling situation, and then from there we encourage curiosity in our class, and we ask the students to formulate questions. Then from the formulated questions, they will develop hypotheses, and from there they will do something to reflect and do some analysis out of what they have discovered from the what have about the hypothesis they have formulated. So what are the merits? It will generate greater interest among the students. This also teaches problem solving like the discovery learning model. And of course, when you ask them to work with team, then this can also enhance teamwork skills. And of course, their learning will be ensured because they engage in an active learning process. And of course, there's a tendency that there could be a long-term knowledge retention that can happen among the learners. What about demerits? So for the demerits, this could be the downside is that there would be poorer standardized testing performance among the students. Sometimes students get embarrassed, and of course, if teacher is unprepared to be facilitating the learning in inquiry method, well, there could be a drawback. There could be a drawback in that um, teacher might be unable to achieve the learning target because of his or her unpreparedness. Now we move on to the experimental method. So these are actually the steps. So there are actually 2, 4, 6, 8, 10, 11 steps in the experimental method. I think you are familiar with experimental method because since elementary you've been engaged into different experiments and that you follow the scientific method. So here we start with sensing and formulating a problem for the study that you are or for you're going to experiment, and then we make inference or hypothesis. um, yes, we formulate our hypothesis or our educated guess, and then we suggest ways and means of testing the hypothesis. This can be brainstormed inside the classroom, and then you design the experiment for younger one. You can assist them in designing the experiment. But for those who are ready, you can probably ask them to do the designing of the experiment, and then designing the experimental procedure. So what are the processes that they are going to undergo in order to answer the problem, and then they perform the experiment. This is the actual experimentation process. Then report the findings. After reporting the findings, they interpret the findings. Then out of the findings that they have, they make conclusions. From the conclusions, they formulate concepts and apply the new concepts. So those are the different steps that you are going to facilitate whenever you are going to employ experimental method in your class. Now let's go to the last. I think this is the last method. So problem solving method. So pupils have to master the product and process of science. So learners should have the ability to confront and respond to problems of life. So in a problem solving method, it's a problem solution process. So take note that problem solving is a planned attack upon a difficulty for the purpose of finding a solution. So whenever you are going to employ problem solving method, you always end up with a solution to the problem that you are confronting. So problem solving is a process of raising a problem in the minds of the students in such a way as to stimulate purposeful thinking for arriving at a rational solution. So it's always a way of thinking and a way of teaching. So problem solving can be either a way of thinking or a way of teaching. So in our case, this could be both because you do problem solving method as a way of teaching, but this could also be a way of thinking for the students. We're going to confront the problem so that confront the problem um, by giving solutions to it. So what are the steps that we are going to follow whenever we use the problem solving? So first is setting the problem. Of course, we define the problem. We should look at what is this problem all about, what are the dimensions of this problem, and then after that we analyze the problem. So that's problem analysis, so that we can understand well what this problem is all about. And then we collect data for all possible clues, we interpret the data, we formulate tentative solution or hypothesis, then we select and test the most likely hypothesis, draw conclusions, and make generalizations, and then apply generalizations to new situations. So, what are the merits of the problem solving? So, children get training in the art of problem solving out of this method. It also develops the thinking and reasoning power of the pupils. It develops the power of critical judgment, as pupils have to think a lot for arriving at correct solution to the problem through the practice. What else? It is also helpful in making the students become resourceful and self-reliant because they have to find ways in order to arrive at the solution to the problem. Then pupils have efficient opportunities to express themselves while discussions are going on. Pupils get training in cooperation and fellow feeling, and it inculcates habits of open-mindedness and tolerance. So it also makes the teaching process more meaningful, and it strengthens the human relations between the teacher and the learners. The pupils get valuable social experiences because they have to be engaging so that they can really understand the problem that they are solving. So what are the demerits? It is difficult on the part of the teacher to organize the content of science according to the needs of the pupils because there are diverse learners, and most probably every year you will get to encounter, or teachers get to encounter different kinds of students, and that sometimes the diverse needs of the students will complicate the planning of the lessons. So it's also time consuming method, and this method is not proper for immature pupils because they cannot follow relevant materials of science properly. So you have to facilitate this to mature pupils, like maybe grade 5 or grade 6. Um, the textbooks and written material on these lines are not easily available. So you have limited resources to use using the this model. And there's a dearth of trained and competent teachers who can put this method into practice. All right, so let me go back again to the statement. Teaching is like fishing. You use different lures for different fish. You use different methods for different learners. So there are different methods that we can use in science teaching. It's really your decision when you teach later on which method is apt for the particular lesson or topics or learning content that you are delivering to the class. And of course, take note that we have to be considering the needs of the learners, and the methods have to be responsive to the needs of the learners. But what methods are also or the learning content has to be considered also in selecting the method that you are going to employ in the class. So there may be different methods, but what's the responsibility of the teacher? The responsibility of the teacher is to select the method that is most appropriate for the students to learn. So with that, let me know what are your thoughts on this. You can comment down in our forum your insights about the different methods that we have discussed this time. So you can write your insights and then put that in our comment boxes so that we can explore more about this methods of teaching in science, particularly in biology and chemistry. So with that, thank you, and enjoy your asynchronous learning experience.